Hello students, welcome to chemistry classes. Today we are going to discuss periodic properties. Last class I told you some periodic properties: atomic radii, ionic radii, ionization energy or ionization enthalpy or ionization potential, electron affinity or electron gain enthalpy, and the last property is electronegativity. From that, first we are going to discuss atomic radius. So, under this topic, what is atomic radius? How atomic radius varies in a group as well as period, and what are the factors which influences this atomic radius. We know that atom and size of an atom is very small. We can't able to imagine the size of an atom in the visible nature, because the size of an atom is approximately 1.2 Armstrong or 1.2 into 10 to the power minus 10 meter. Size of an atom is a very small quantity. Therefore, we can't able to identify or find out the radii of atom in a specific manner. So, how to identify or find out the size of an atom? We know that atoms are united together or combined together. One atom is associated with another atom. Let us consider an atom of A is combined with another one atom A. A and A combine together or bind together by the bond called single bond. Single bond. This bond may be covalent or it may be ionic. Covalent means the atoms, that is A and B, are non-metallic in nature. Covalent means A and A are non-metallic. Suppose ionic means these are metal atoms. Metal atoms are present in the form of A and A. Let us consider or how to define atomic radius. Simple manner is an atom A is a center of the atom, nucleus. This is a valence cell. Simply you define what is atomic radius. Distance between center of the nucleus and outermost orbit of an atom, that is called atomic radius. Atom, that is called atomic radius. Distance between center of the nucleus and outermost orbit of an atom. The atom that is in the covalent in nature, or it may be ionic in nature. I already told you the atoms cannot exist in the single moiety. Therefore, they are united together. Suppose two atoms are linked by or connected by a single covalent bond or an ionic bond or a metallic bond. So, how to define atomic radius in the molecular form? For example, here is an atom A. This is another one atom A and its center. Distance between center of the nucleus and outermost orbit of an atom. The point at which electron density is effectively zero. This point is called nodal point. So, what is node or nodal point means? Those molecular form and this electron density is effectively zero. Electron density is effectively zero. The point is called nodal point. Now, you define what is atomic radius. Distance between center of the nuclei of two adjacent atoms and the point at which the electron density is effectively zero are called atomic radius. Suppose the non-metallic atoms are linked together, it is called covalent radius. Metal atoms are linked together, ionic radius or metallic radius. Ionic radius or the metallic radius. Let us consider chlorine. Two chlorine atoms are linked by a covalent bond. Covalent bond. The bond length of chlorine single bond is 198 picometer. Bond length of this chlorine single bond is 198 picometer. How to find out the radii of an atom? So it is called diameter of chlorine single bond is 198 picometer. So diameter is the sum of radii of chlorine plus radii of chlorine gives diameter of chlorine single bond. This value is given, or 2 into radii of chlorine, that is equal to diameter of chlorine single bond. Therefore, radii of chlorine atom is equal to diameter of chlorine single bond divided by 2. Therefore, radii of chlorine atom is equal to 198 divided by 2, that is equal to 99 picometer. 99 picometer. So this is a way to calculate the radii of covalent molecule. Radii of covalent molecule, especially in the case of especially chlorine. Suppose copper atom. Let us consider the copper atom. The copper atoms are united together, and this internuclear distance of copper single bond. Copper single bond, that is equal to 256 picometer. From this we can calculate the radii of copper. You must remember certain non-metals. For example, hydrogen single bond. The radii of hydrogen single bond, that is 74 picometer. 74 picometer. Fluorine single bond 144 picometer. Chlorine single bond 198 picometer. Bromine single bond 228 picometer. Carbon single bond 154 picometer. So these are the standard values. You must learn this for the part of calculations. Hydrogen single bond 74 picometer. Therefore, the radii of hydrogen atom, that is equal to 37 picometer. Fluorine single bond 144 picometer. Chlorine, bromine, carbon single bond 154 picometer. So this is the atomic radii of certain or specific atoms. Now, how atomic radius varies in a group as well as in the period. I already told you the group and the periods. Totally 18 groups are present and 7 periods are present. 18 groups and 7 periods are present. So in the group, you must remember top to bottom. Period, left to right. How atomic radius varies from left to right. In left to right, you remember the second period of periodic table. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Left to right, atomic number 3, 4, 5, 6, 7, 8, 9. Left to right, atomic number increases by 1. That means the electrons are enter into same main energy level. Electrons are enter into same main energy level. Here second 2 electrons are present, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So 8 electrons are accommodated. Left to right, the electrons enter into same main energy level, so that the force of attraction between nucleus and the valence cell electron increases. Force of attraction between nucleus and the valence cell electron increases. That means the valence cell electrons are tightly or strongly held together by the nucleus. Therefore, reduction in size takes place. Reduction in size takes place due to heavier force of attraction between nucleus and the valence cell electron. Look at this data. Lithium to fluorine, 152 picometer to finally 64 picometer. 64 picometer, size of an atom decreases. Atomic radius decreases from left to right. Atomic radius decreases from left to right. So what about the top to bottom? As we move in the group lithium, sodium, potassium, rubidium and cesium. Look at the data. Size of an atom, top to bottom, increases. Why size of an atom increases in a group? Why size of an atom increases in a group? The electrons, added electrons enter into higher main energy level or new main energy level. Higher main energy level or new main energy level. So that the force of attraction between the nucleus and the valence cell electron decreases. Force of attraction between nucleus and the valence cell electron decreases. Size of an atom increases. This is an important result. Top to bottom, size of an atom increases. Top to bottom, size of an atom increases. Now, what about the noble gases? Noble gases we can't include it for comparing the size of an atom. Why noble gases are not included for comparing the size of an atom? Noble gases are exist in the form of gases and exist in the form of individual atoms. They cannot bind together because there will be no force of attraction between two adjacent atoms, and we cannot include or find out the size of atom in the case of noble gases. So this is all about the atomic radius. Now the second similar concept, that is ionic radii. What is ionic radii? How ionic radii varies from left to right in the periodic table and top to bottom in the periodic table. What is isoelectronic species, and how to compare the size of atom and its cation or the anion. Listen, atomic radius. The atomic radius is defined as distance between center of the nucleus and outermost orbit of the ion. Ion is called ionic radius. Ionic radius. First of all, you must know how the ions are formed. For example, X is an atom. Accept the electron to form X minus. This is anion. Ions with negative charge is called anion. X is an atom. Loss on electron, it gives X plus, that is cation. This is anion, it is cation. Negatively charged species is called anion, positively charged species is called cation. For example, sodium, atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. The valence cell consists of one electron. These electrons are removed. It becomes Na plus ion. Na plus ion. Na plus ion is a cationic species. Chlorine, atomic number 17. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. The valence cell, suppose one electron is added, so it becomes Cl minus, positively charged species. Here it is a negatively charged species. The distance between center of the nucleus and the outermost orbit of ion is called ionic radii. Ionic radii. Now comparing the size of Na and Na plus, you must remember two important concepts. The size of cation is smaller than its parent atom. The size of cation is smaller than its parent atom. Size of cation, that is Na plus ion, is smaller than Na. Na plus ion is smaller than Na. Look at the size of sodium. Sodium 186 picometer. Sodium plus 95 picometer. So, I am comparing the size. And the similar way, the size of anion is larger than its parent atom. The size of anion is larger than its parent atom, that is Cl minus is greater than Cl. Cl minus is greater than Cl. In some cases, in the examination point of view, Cl minus is greater than Cl. Justify. How to justify? Cl minus consists of 18 electrons. Chlorine consists of 17 electrons. But the nuclear charge of both Cl minus and Cl are same. Nuclear charge Z are same. That is 17. Therefore, the electrostatic force of attraction between this nucleus and the valence shell electron decides the size of an atom. Force of attraction between nucleus and the valence shell electron decides the size of an atom. Now, what is isoelectronic species? Isoelectronic species. Isoelectronic species means either ions or metal atoms having same number of electrons are called isoelectronic species. Let us consider O2 minus, F minus, Na plus, Mg2 plus. Let us consider this, considering this ions. O2 minus, number of electrons 10, F minus, number of electron 10s, Na plus, number of electrons 10s, Mg2 plus, number of electron 10s. All these cases, number of electrons are same. Therefore, these species are called as isoelectronic species. Isoelectronic species, how to predict the size of an atom, or how size of an atom increases, which one is larger and which one is smaller. Here also you must learn one generalization. Cations with larger positive charge are smaller in size. Cations with larger positive charges are smaller in size. Which one is smaller? Comparing Na plus and Mg2 plus, Mg2 plus is smaller than Na plus, because the force of attraction is less. Here force of attraction is maximum. And in the case of anions with larger negative charges are larger in size than the smaller sized anions. So O2 minus is larger in size than F minus. So this is isoelectronic species and their size comparison about this isoelectronic species. How this atomic radii, ionic radii varies in the group and the period. Similar way of atomic radii, ionic radii also varies from left to right, same reason. From left to right, ionic radii decreases, top to bottom, ionic radii increases. So, in this module you can learn about this, one of the important periodic property called atomic radius and ionic radius. I concluded this topic by some questions. So, first of all, so what is atomic and ionic radii? How atomic radii and ionic radii varies in the period as well as in the group, or give the reason for that. Why noble gases not included for comparing size of the atomic radii? Then what is isoelectronic species? How to predict the size of the isoelectronic species with their charges or with their charges. So, these are the some important questions may ask in the examination point of view. You learn the lesson very well and go through your textbook also. If you have any doubts, you can ask. Thank you.